In this example, we're asked to determine the net change and average rate of change of the function f of x equals 3 minus x squared between x equals 5 and x equals 5 plus h. So in this case, instead of using subscripts, let me call the first value of x a, and the second value of x b. We could call them x1 and x2, but just to avoid the subscripts, let's call them a and b. So in this case, b is 5 plus h, and a is 5. So f of b is equal to 3 minus 5 plus h squared. Remember, whenever we square a binomial, we get a trinomial. We square the first term, take twice the product of the terms, and square the last. And so when we simplify this, we get negative 22 minus 10h minus h squared. And our f of a is simply equal to 3 minus 5 squared, which is negative 22. So our f of b minus f of a is equal to negative 22 minus 10h minus h squared, subtract a negative 22, and the 22's cancel to leave us with negative 10h plus a negative h squared, or minus h squared. And our average rate of change would be f of b minus f of a all over b minus a. And notice that our b minus a is 5 plus h minus h, minus 5, and our f of b minus f of a is our net change. The denominator comes out to be h, and notice from the net change that was computed above that h is a common factor. So factoring it out of the net change, we get negative 10 minus h. We cancel the common factors to have an average rate of change, negative 10 minus h. So in this case, both the net change and the average rate of change are themselves functions of the value of h, where h determined the distance between a and b. So again, if we look at the graph, I'll let you confirm that we have the graph of y equals f of x is a parabola opening down. The vertex would be 0, 3. But both of the values, 5 and 5 plus h, will be to the right of 0, 3 if the h is positive, which we will assume it is. So we have the point 5, negative 22, and then this second point, which is 5 plus h, comma, negative 22 minus 10h minus h squared. So if h were 1, that would give us the point 6, comma, negative 22 minus 10 minus 1, or 6 minus 33. And so when we find the slope of the line joining these points, we're going, in this case, down and to the right. If I put in the value h in my of h equals 1 in my average rate of change, we'd get the average rate of change would be negative 10 minus 1, which would be negative 11. And we can confirm we would get the same answer here because we'd be moving to the right 1 while we moved down 11. From 5, negative 22 to 6, negative 23. And so the h is considered a variable, and as h changes, so does the average rate of change.